Hi folks, welcome to your first experiment. My name is Vinicius. I'm going to be one of your TA for this semester. And in this experiment today, we'll learn about the calorimetry of reactions and heat transfer. So this experiment will be divided into two parts. So in the first part of this experiment, we'll react hydrochloric acid and sodium hydroxide inside of a calorimeter, which is this little guy over here. You see we have a foam jacket and a test tube. So we mix the acid and base in this test tube, and the reaction that will happen is an exothermic reaction. It will release heat. So this heat released will be absorbed by the calorimeter and the solution. And since we know the concentrations of the acid and base, we can calculate the amount of heat produced. We will also determine the mass of the solution and the difference in temperature, and with that values, we'll be able to calculate the heat capacity of the calorimeter. Once we know the heat capacity of the calorimeter, we move on to the second part, where we will determine the concentration of a strong acid. This process is similar to that of part 1. However, the heat capacity of the calorimeter has already been determined, which will allow you to calculate the molarity of the unknown solution. Once you have data, you carry out your calculations, and you should be attentive to the number of the decimal places or significant figures you use to report your results. You can find plenty of information in your lab manual, and I strongly recommend you to read it before starting your calculations. So that's it for today, folks. I hope you enjoy your experiment, and we'll see you later.
In part 1 of this experiment, the heat capacity of the calorimeter will be determined. Assemble and weigh the calorimeter. The calorimeter consists of a styrofoam jacket, a test tube, and a metal stirrer. The test tube of the calorimeter must be clean and dry. Then, the calorimeter must be weighed using the top-loading balance. Remember to tare the balance first. Record the mass of the calorimeter. Obtain the reactants. Obtain the reactants, both sodium hydroxide and hydrochloric acid, from the large carboys set up in the lab. Record necessary concentrations as specified in the lab manual. Prepare the burette. Prior to using the burette, you must clean it. First, rinse the burette with deionized water from a wash bottle. Drain the water through the delivery tip into a waste beaker. Then add a small amount, about 5 milliliters, of hydrochloric acid to the burette. Roll and tip the burette to ensure all inner surfaces are coated. Have a waste beaker set up to catch any spills. Then, drain the hydrochloric acid solution through the burette tip into a waste beaker. Dispense the reactants. Fill the burette with hydrochloric acid. Record the initial volume reading. A white card or paper may be placed behind the burette to assist with this reading. Dispense the hydrochloric acid directly into the calorimeter apparatus. Record the final volume reading on the burette.
Set up the LabQuest. The temperature sensor is automatically detected. The mode defaults to time-based. To set the digital display to show 2 decimal places, touch the table icon. Double tap on the heading Temperature. From the drop-down menu, choose 2, then tap OK. To set the sample rate to be 2 seconds, touch the meter screen again, tap on the mode box or any box on the right-hand side of the screen, touch the interval box and type in 2. Tap Done, then tap OK.
Measure the temperature of the reactants. Measure the temperature of the acid in the calorimeter using the temperature sensor. Once the measurement is complete, remove the temperature sensor, allowing any acid to drip back into the test tube. Then wipe the sensor with a damp paper towel. Measure the temperature of the base in the graduated cylinder. If the temperature differs by more than 2 degrees Celsius from that of the acid, run hot or cold water on the outside of the graduated cylinder until the temperature is within 2 degrees.
Initiate the reaction. Pour the sodium hydroxide into the large test tube. Tap on Collect on the LabQuest unit. After the sodium hydroxide has been added, insert the temperature sensor. Begin to slowly and steadily stir the contents of the test tube for 180 seconds. Ensure the temperature sensor is not moving up and down while stirring. Note, data collection has been speeded up for the purposes of this video. The experiment will automatically stop after 180 seconds. Analyze the plot. From the graph, it is easy to see that the initial data points are not reliable. These points should not be used in the calculation of the final temperature. Touch the screen and drag to highlight the area of the line that does not include the initial data points. Tap on Analyze, tap on Curve Fit, and check the box beside Temperature. Various curve fits can be examined. From the drop-down menu, choose between linear or quadratic. Select the line that best fits where RMSE is closest to 0. Record the values that are specified in the lab manual.
Reweigh the calorimeter. Reweigh the calorimeter and its contents after the neutralization reaction. Record the mass of the calorimeter and its contents. In part 2 of this experiment, the molarity of a strong acid will be determined. For part 2, the same procedure will be used as in part 1. However, the standardized hydrochloric acid will be replaced with a hydrochloric acid solution of unknown molarity.